Okay, chapter 2, day 4. Today we're going to focus on a topic that occurs on pretty much every Algebra 2 trig exam. And what we're going to focus on is how do we simplify complex fractions. And that's kind of new for us. So a complex fraction, what is it? A complex fraction is a fraction within a fraction. So we call them complex fractions when there's more than one fraction within a fraction. It's like fractions on top of fractions. An example of a complex fraction might be 3/4 over 6. This is a fraction. This is a fraction. Remember, we could write this as 6 over 1 and it's still a fraction. Fractions within fractions are complex fractions. Okay? So how do we simplify them now when we have multiple fractions? So a typical example that we might see is simplify b over 10 plus a half over b squared over 25 minus 1. So, first step, you have to find the common denominator of all of the little denominators. So notice, here's a big fraction line right here. This is a little fraction on this big fraction. Little fraction, and this I can actually write as a fraction. That's a little fraction too. So my common denominator of all of the little fractions is the same thing we just did in class, which is finding common denominators. But now I'm only going to focus on the 10, the 2, the 25, and the 1, because those are all the little denominators. So a number they can go into, that 10, 2, and 25 can go into, well, 25 is, I have to start there. 10 and 2 can't go into it. But 50 they can go into. 50 is a number that 25 can go into, 10 and 2. Okay, so there's my common denominator. First thing we have to do, find the common denominator. Now, the next thing is to multiply all numerators. So, again, on the top, here's a numerator, here's a numerator, here's a numerator, here's a numerator. Multiply all numerators by the common denominator. And what do? We actually don't multiply yet. We just write it next to each numerator. So I'm going to take the number 50. I'm going to write that number 50 next to each numerator. So I'm going to go 50 times that. 50 times that one. 50 times that. 50 times that. Next to each numerator. So don't be sloppy and put it like down here. It has to go, not here, it has to go up here next to the numerator. Okay, so not down here, right up here next to the numerator. And I'm actually not multiplying anything out yet. I'm just showing that I will multiply. All right? But here's the nice part about this problem. Step 3 is to reduce each little fraction. Reduce each little fraction. So before we go any farther, we're going to go up here and we're going to reduce each fraction. So 50 and 10. 10 goes into 10 once and goes into 50 5 times. If this doesn't get fully reduced, then you didn't pick a common denominator. You'd have to try again. 2 goes into 50 25 times. 25 goes into 50 twice, and 1 goes into 50. There's nothing to reduce there. So, step 3, reduce each little fraction. There, we've now reduced. Next step, rewrite the whole thing, but as one fraction. So you rewrite what is left as one fraction. So, what do I have left on top and bottom? Well, I'm going to put a fraction line out here. And what do I have left at the top? I have 5 times b, which is 5b, plus 1 times 25 is 25, over 2b squared minus 50. Okay, whatever's left on top goes on top. Whatever's left on the bottom goes on the bottom. Notice all of your little fractions now are gone, and you're left with just a numerator and a denominator. If they didn't reduce down, then you pick the wrong common denominator. Last step, factor and reduce. We need to, if possible, and many times it will be possible, to factor and reduce, trying to simplify the answer. So we're not done yet. We now have to factor. Well, 5b plus 25, common factor is 5, so I got a 5, and then I have a b plus 5. Over, well, I can take out a 2 here, and this is b squared minus 25. Oh, but wait, there's more, just like those infomercials. B squared minus 25 really is a difference of perfect squares. B plus 5, B minus 5. 2 just goes along for the ride. So factor and reduce. So now what do I have left? I have a 5. Let's see if I have room to write it underneath it. I'll just write it over here. 5 over 2 b minus 5. We're not setting anything equal to anything because we're not solving. The directions are to simplify. So again, take all the little denominators, find what a common one, write it next to each numerator, reduce, rewrite what's left. So 5 times b plus 25 over 2b squared minus 50. After you reduce, factor if possible, factor completely, reduce if possible, and now you have an answer. And that's how you do it. Let's take a look at another example. Okay, so here's one. So, common denominator. Well, I have, I'm going to put over 1. Anything that's not a fraction, I'm going to put over 1, make my life easier. I have a 4x, an x squared, a 1, and an x. Well, 4 I know has to be in there. I need the letter x, and here's the thing. In order to get x squared to reduce, I have to have the highest power that I see, which is x squared. Okay? So here we are, 4x squared. Okay? Write it next to each numerator. There. So common denominator, write it. Next step, reduce. So 4x with 4, and then the squared is gone on the x. X squared, nothing to reduce here. X with x squared, leaving me just x. So what do I got? I got 6x plus 3 times 4 is 12. 4x squared times 2 is 8x squared minus 4x. Okay, factorable. Lots of times it's going to be GCF factoring or difference of squares. Lots of times. Not always, but quite a few times. Take out a 6, x plus 2. Take out a 4x, and I got 2x minus 1. 6 and 4 I can reduce. 2 goes into 6 3 times, goes into 4 twice. So my answer is 3x plus 2 over 2x minus 1. And that's it for today. So that's chapter 2, day 4.